so today's lesson is lesson 2 on proportional relationships. Our first example here, we have a self-serve frozen yogurt store that opened this summer, and it sells yogurt at a price based upon the total weight of the yogurt and its toppings in a dish. Each member of Isabel's family weighed his dish, and this is what they found. The question states, determine if the cost is proportional to the weight. So we always want to make sure that we identify what we're trying to figure out. And so looking at this particular problem, across the top we see weight in ounces, and across the bottom we see cost. So this one right here, maybe this is dad, maybe this is mom, maybe that's Isabel, and maybe this is brother. And so what we want to see is everybody paying the same amount per ounce? So pause your video for a minute. I want you to work with those numbers that you see in this table and see if you can figure out whether or not you think that everybody's paying the same amount per ounce. So if you remember back to lesson 1, we've talked about how we need to take money and divide it by the amount we're given, whether that's packs of pencils or in this case, cost of yogurt. And so doing that, we can take the bottom number here and divide it by the top number. When we do this for all values in the table, we'll get that each one of these is 40 cents per ounce. That's our rate. We can see that the rate is the same. Every single one of these is 40 cents per ounce. And so what that means for us is the cost is, let me zoom in some more. Sorry guys. Proportional. Now it's still breaking out. To the weight. So the cost is proportional to the weight. And the reason we know this is because we divided the bottom by the top. Now, a couple of things that I want to show you here. You're going to be using a lot of tables and a lot of double number lines. And so what we're going to start doing is we're going to start recognizing the top values as X and the bottom values as Y. So X is an input. If you don't put any yogurt in your cup or any toppings, then you don't pay any money. So Y is your output. Y is what you get. And so you take your output divided by your input to get your constant of proportionality. And we're going to talk some more about that in just a minute. So let's look at the second example, cooking cheat sheet. So the back of a recipe book, a diagram provides easy conversions to use while cooking. Sometimes you have a measuring cup and you need to be able to measure ounces. And sometimes you're given ounces and you need to know how many cups that might be. And so we just want to make sure that those are the same. So again, if we're using the same principle, X to Y, we're just going to take these values and divide them by the top value and see if we get the same number every time. So 4 divided by 1/2 or 5/10, 8 divided by 1, 12 divided by 1.5, and 16 divided by 2. So 2 of those that are very easy to do would be this one and this one. You could probably do those in your head, and those are both 8. Now the other 2 are a little more involved. You can do them by hand. You should know how to do them by hand. But you can also just think. Let's think about this one. If we have 4 candy bars, how many halves do you have in one candy bar? If you take one candy bar, you have 2 halves. So if you have 4 candy bars, you have 8 halves. And the same thing for 12 divided by 1.5. You can put it in your calculator, you can convert it to a decimal, and make sure that you move your decimal and divide properly. And we'll see that we also get 8. So every single time we're getting that same value of 8. What that tells us is that the ounces are proportional to the cups. So proportional, I'm going to underline it up here at the top. In case you can't read my writing, there it is. So what is this number called? Because these are your x values and these are your y values. So what is this set called? Well, the number that you get across the top is called k. We refer to this as the constant of proportionality. So we're going to have to remember that one. Let's look at exercise 1. So Jose's physical education class, they are visiting activity stations. Each station has a chart depicting how many calories on average that would be burned by completing that activity. Is the number of calories burned proportional to time? How do you know? And then part B says, if Jose jumped rope for 6.5 minutes, how many calories would he expect burned? So you need to work on this one by yourself. Since this is an exercise, you are practicing the skill that I just taught you on the other 2 problems. So look at your double number line, label it with your x and y, see if you can divide to get the constant of proportionality, and then determine if it is proportional and explain how you know. Go ahead and pause your video and work on that for just a few minutes. So let's check our work and see how we did. So if I'm going to label this would be x, because you have to put in time exercised in order to get y, or the output of calories burned. So we know that we're going to do y divided by x to figure out our k, or our constant of proportionality. So what you should have done was divided the bottom number by the top number every time, and you should get 11 across the top. Notice this value of zeros here. This is because if you don't exercise at all, you're not burning any calories. So 0 is often the starting point, and it is the starting point in proportional relationships. So is the number of calories burned proportional to time? Yes, it is proportional, and I'm going to shorten that to prop, because you burn 11 calories per minute. Okay, so looking at the next one. If he jumped rope for 6.5 minutes, how many calories should he expect to burn? Remember that we answered these questions up here. So if it's 11 calories per minute, and we know we're calling that K, we know that X is our minutes, and in this problem our minutes is 6.5. We're trying to figure out calories. Y is our calories. That's what we don't know. And when you don't know it, you use a variable. So here's the relationship. There's a standard equation format. The standard equation is y equals kx. I want you to put that down in your notes and call it standard equation. You're going to use this for the rest of your math career. So what this says is that if we have our constant of proportionality, we multiply it by our x and we get our y. So in this case, we know our constant of proportionality is 11. We know our minutes is 6.5, or x, and so we can get our y, or our calories burned. And so our problem becomes 6.5 times 11. So you can multiply by hand, you can put that in your calculator. Either way, you're going to realize that the total calories burned in 6.5 minutes (71.5 calories). Make sure that you've answered all the questions. So the only part we had to answer was how many calories would you burn. And so we've done that and we've circled our answer. Let's look at example number 3. So Alex has spent the summer helping out his family's business. He's hoping to earn enough money to buy a new $220 gaming system by the end of the summer. Halfway through the summer, after working for 4 weeks, he had earned $112. Alex wonders, if I continue to work and earn money at this rate, will I have enough money by the end of the summer for the system? To determine if he'll have enough money, he decided to make a table. He entered his total money earned at the end of week 1 and his total money earned at the end of week 4. Part A, work with a partner to answer Alex's question. So let's go back into our reading and look and see what his question is. His question states, if he continues to work at this rate, will he have enough money to buy the gaming system? And this is how much the gaming system is. So we need to see if he's going to have that much money. Now he put some information into the table. So if we're looking at week 0, if he's done no work at all, does he earn any money? Okay, so stop right now, find yourself a partner to work with or work by yourself, and see if you can figure out the rest of the values for the table. Pause your video and work now. So in week 1, we have he's made $28. So if he works for 2 weeks and he's making $28 every week, we would simply double the 28 and realize that he's made $56 in 2 weeks. So every single time, we are adding another $28. So this would be 84, this would be 140, this would be 168, 196, and in week 8, we have $224. So in this one, you were not trying to find K. What were you trying to find? You were trying to find Y. However, you were giving the unit rate right here, and you can use that unit rate to determine what K is. So when X is 1, this is K. When X is 1, this is K. So our K is 28. We're still looking at the standard equation, but this time we know different information. We're trying to get Y, we know K, we know X. K is 28, because we looked at when the X value is 1, what is Y, and we know that X is the weeks that he's worked. And so all we have to do is substitute that in. So 28, say, times 3 to see that we get 84, or 28 times 5 to see what we get. So, answering Alex's question, at the end of the summer, which is after 8 weeks, will he have enough money to buy the $220 gaming system? The answer is yes, he will have enough. It doesn't ask us to say how we know, but we know because 220 is how much the system is, and that is less than what he's making, which is $224. So there's some support for that answer. Part B, are Alex's total earnings proportional to the number of weeks he worked, and how do you know? Yes, it is proportional, or prop. We know the constant is $28 per week. If we wanted to write that in more math terms, we would say, yes, it's prop K equals 28. So either one of these answers would be sufficient. Okay, go ahead and stop your video and work on your problem set.